Question 1. What is Adobe Experience Manager, and what problem does it solve? Adobe Experience Manager, or AEM, is an enterprise-level content management system built on top of open-source technologies like Apache Sling, Apache Felix OSGi, and the Java Content Repository Standard. It solves the fundamental problem of managing and delivering digital experiences at scale across websites, mobile apps, and other digital channels. Before AEM, large enterprises struggled with disconnected tools, one system for managing content, another for digital assets, another for forms, and yet another for personalization. AEM consolidates all of this into a single unified platform. It allows marketing teams to create and publish content without depending on developers for every change, while still giving developers a powerful, extensible framework. Companies like Adobe, Nike, and major banks use AEM to manage thousands of web pages, images, and campaigns across global markets. For a Java developer, AEM is especially approachable because its core APIs, component development, and workflow logic all use standard Java patterns. Question 2. What are the core technologies that power AEM? AEM is built on 4 core open-source technologies. First is the Java Content Repository, or JCR, which is a standardized Java API defined in JSR 170 and JSR 283. JCR provides a hierarchical, tree-structured content store, think of it like a file system but for web content, with built-in support for versioning, access control, search, and event observation. Second is Apache Jackrabbit Oak, which is the actual implementation of JCR used in modern AEM versions. Oak replaced the original Jackrabbit implementation and offers better scalability. Third is Apache Sling, a web application framework built on top of JCR. Sling introduces the concept of resource-oriented computing. Every URL maps to a JCR node, and Sling resolves which script or Sling model to use to render that node. Fourth is Apache Felix, which is the OSGi container used by AEM. OSGi allows AEM to be modular. Services and components can be installed, updated, or removed at runtime without restarting the server. Understanding these 4 layers is fundamental to AEM development. Question 3. What is the JCR node structure in AEM? How is content stored? The Java Content Repository stores all AEM content as a tree of nodes, where each node has a type and can have properties and child nodes. At the very root is the /character, the root node. Under it are major paths like /content, /apps, /libs, /conf, /var, /etc., and /dam. The /content path stores all your actual website pages and their content. For example, a homepage might live at /content /mysite/n/home. The /apps path stores your custom code, components, templates, Clientlibs, and OSGi configurations. The /libs path contains AEM's out-of-the-box components and configurations. You should never modify /libs directly. The /dam path under /conf stores all digital assets uploaded via assets. Each node has a primary type like NT, folder, NT, file, CQ, page, or CQ, component. Page nodes of type CQ, page always have a child node called JCR, content, which holds the actual properties of the page, title, template reference, component tree, and authored content. Properties on nodes can be string, long, boolean, date, binary, or multi-value arrays. This hierarchical structure is what Sling traverses when resolving requests. Question 4. Explain the Sling resource resolution process. How does a URL become content? When a request comes into AEM, Apache Sling resolves it through a well-defined process called resource resolution. First, Sling takes the URL and strips the context path and any selectors, extension, and suffix. For example, given the URL /content /mysite/n/home.model.json/data, Sling identifies the resource path as /content /mysite/n/home, the selector as model, the extension as JSON, and the suffix as /data. Sling then looks up the JCR repository at the resolved path to find the resource. If it finds a node there, it creates a resource object wrapping that node. Next, Sling determines which script or servlet to use to render the resource. It looks at the resource type, stored in the Sling resource type property of the node. For example, if Sling resource type is mysite/components/hero, Sling will look for a rendering script in /apps/mysite/components/hero. It matches scripts by name according to the extension and selector, so for .html extension it looks for hero.html, for .model.json it looks for a registered Sling model exporter. This resource-oriented approach means every piece of content has a unique URL and a component that knows how to render it, making AEM extremely flexible and predictable. Question 5. What is OSGi and why is it important in AEM? OSGi stands for Open Services Gateway Initiative and it is a Java modularization standard. In AEM, Apache Felix provides the OSGi runtime, also called the OSGi container. OSGi allows AEM to be divided into bundles. These are essentially JR files with extra metadata in their manifest.mf that declare what packages they export and import. This makes AEM modular and dynamic. You can deploy a new bundle, update it, or stop it without restarting the entire server. Every AEM feature, the DAM, the workflow engine, the replication agent, the authentication handler, is a bundle. For developers, OSGi means your custom code is also packaged as a bundle. You annotate Java classes with OSGi annotations like @component and @service to register them as OSGi services. Other bundles can then @reference your service through dependency injection. The OSGi configuration system allows you to externalize configuration values, like API endpoints, timeouts, or feature flags, and change them at runtime through the Felix web console or through configuration files. This is why you often see AEM config classes with @designate and @object class definition annotations in AEM projects. The Felix web console @system/console is your debugging window into all active bundles, services, and configurations. Question 6. What is a Sling model? How do you create one? A Sling model is a Java class or interface annotated with that model that adapts a JCR resource or a Sling HTTP servlet request to a plain Java object. Sling models replace older approaches like JSP scriptlets and WCMU's POJO and are the modern, recommended way to back AEM components with Java logic. To create a Sling model, you first add the @model annotation with adaptables set to resource.class or Sling HTTP servlet request.class, and set the adapters to the class or interface this model can be adapted to. Inside the class, you use @valueMapValue to inject a JCR property by name, @inject to inject other OSGi services or child resources, @childResource to get a child node as another Sling model, @requestAttribute for request parameters, and @scriptVariable for HTL script variables. You can also define @postConstruct methods that run after all injections complete, perfect for computed properties. The model becomes available in HTL templates via the data_use directive. Sling models support exporter annotations like @exporter with name JSON and extensions JSON, which automatically expose the model as a JSON endpoint. This is fundamental to AEM Headless and SPA implementations. A key advantage of Sling models over older approaches is that they are pure Java with clear separation of concerns and are easily unit testable with frameworks like JUnit and Mockito. Question 7. What is the difference between /apps and /libs in AEM? This is one of the most important concepts in AEM development and a very common interview question. The /libs path contains all of Adobe's out-of-the-box components, templates, OSGi configurations, workflows, and services. Think of it as the vendor-provided code. You should never modify anything under /libs directly. The /apps path is where all your custom application code lives. It contains your custom components, templates, OSGi configurations, client libraries, I18N translations, and any overlays. When AEM resolves a request, the Sling resource merger gives /apps priority over /libs. This means if you create a node at /apps/myapp/components/text with Sling resource supertype pointing to /libs/wcm/foundations/components/text, your component inherits from the core component but can override specific parts. Overlaying is different from overriding. An overlay means creating a copy of the /libs path under /apps, for example, /apps/wcm/core/content/sites, to modify AEM's admin interfaces. Overriding means using the Sling resource supertype inheritance. The rule of thumb is, always work in /apps, use Sling resource supertype to inherit from /libs components, and overlay only when absolutely necessary. This separation ensures your customizations survive AEM upgrades because Adobe only updates /libs, not /apps. Question 8. What are AEM components? Explain their anatomy. An AEM component is the fundamental building block of page content. It represents a discrete piece of functionality, a hero banner, a text block, a carousel, a navigation menu. Technically, a component is a node under /apps with a primary type of CQ component. Every component has a required set of files and an optional set. The required file is the HTL template, typically named after the component, like hero.html. This file contains the markup and uses HTL expressions to render dynamic content. The component node itself has properties like JCR, title for the display name shown in the authoring interface, component group to control which author palette it appears in, and Sling resource supertype if it inherits from another component. Optional files include a_cq_dialog/.content.xml, which defines the touch UI dialog, the form authors use to configure the component. A_cq_edit config.xml controls authoring behaviors like drag and drop, in-place editing, and empty placeholder display. A_cq_design_dialog defines template level configuration. A Clientlib folder contains the component's CSS and JavaScript. A thumbnail.png provides a preview image in the component browser. And a Java or Sling model class backed by the component provides the business logic. Modern AEM projects use core components as base components and extend them via Sling resource supertype rather than building everything from scratch. Question 9. What are AEM core components and why should you use them? AEM core components are a standard set of production-ready components maintained by Adobe. They cover common web patterns like page, navigation, breadcrumb, title, text, image, list, teaser, button, embed, form elements, table of contents, and many more. There are several compelling reasons to use core components as your foundation. First, they are built to modern AEM best practices. They use Sling models with exporters, proper HTML templates, comprehensive dialog configurations, and follow the style system pattern. Second, they are fully accessible, following WCAG 2.1 AA guidelines. Third, they are continuously maintained by Adobe and have an active open source community on GitHub. Fourth, they implement the content fragment and experience fragment patterns out of the box. Fifth, they support headless AEM delivery with built-in JSON exporters. In your project, you inherit from core components by setting Sling resource supertype to the appropriate core component path, for example core/wcm/components/title/v3/title. Then you can override only what you need, the dialog, the HTML template, or the Sling model. This approach dramatically reduces development time and ensures you benefit from Adobe's ongoing improvements and bug fixes. For any AEM interview, being familiar with core components and knowing how to extend them is essential. Question 10. What is HTML template language, and how is it different from JSP? HTML, formerly known as Sitely, is AEM's recommended templating language introduced with AEM 6.0. It replaces JSP as the preferred way to write component markup. HTML uses HTML attributes prefixed with DataSly to add logic to standard HTML. For example, DataSly use loads a Sling model or use API class, DataSly text sets the text content of an element, DataSly attribute sets attributes, DataSly list iterates over a collection, DataSly test conditionally shows or hides an element, and DataSly include includes another HTML file. The key advantage of HTML over JSP is security. HTML automatically applies XSS escaping appropriate to the context, HTML, attribute, JavaScript, URI, without the developer needing to remember to call escaping functions. In JSP, forgetting to escape a value creates XSS vulnerabilities. HTML is also designed to be readable by both developers and front-end designers because the template is valid HTML with data attributes. JSP mixes Java code directly into HTML, making it harder to maintain. HTML is intentionally limited. You cannot write arbitrary Java expressions, which forces a clean separation between view and logic. All business logic must go into use API classes or Sling models that are loaded via DataSly use. This makes components more testable and maintainable. For Java developers coming to AEM, learning HTML takes less than a day but is fundamental to component development. Question 11. Explain the AEM template system, editable templates versus static templates. AEM has two template systems, the older static templates and the modern editable templates introduced in AEM 6.2. Static templates are defined as nodes under /apps/urap/templates. They specify the page component, the allowed child components, and the initial content structure. Authors cannot modify which components are allowed, that is determined by the developer at template creation time. Static templates are simple but inflexible. Editable templates, also called policies-based templates, are stored in /conf/urap/settings/wcm/templates and are created and managed by template authors through the AEM interface at Tools Templates. They have three sections: structure, initial content, and layout. In the structure section, template authors lock certain components like the header and footer so page authors cannot move or delete them. They define the layout container and apply policies to control which components are allowed. In the initial content section, they pre-populate content that appears on new pages created from this template. In the layout section, they define breakpoint behavior for responsive layout. Policies are stored in /conf/urap/settings/wcm/policies and can be shared across multiple templates. For any modern AEM project, editable templates are the standard. They give business users more control while keeping governance through policies and the ability for developers to lock structure elements. Question 12. What is the AEM style system? The AEM style system, introduced in AEM 6.3, allows template authors and page authors to apply visual styling variations to components without needing developer involvement for each variant. It is a powerful feature that bridges the gap between business requirements for design flexibility and the developer's need for clean, maintainable code. Here is how it works. Developers define CSS classes for different visual styles of a component and configure these styles in the component's policy dialog. For example, a button component might have styles called primary, secondary, and ghost. Each style maps to a CSS class. Template authors, in the template editor, enable specific styles for specific components. Page authors, when editing a component on a page, can then open the style picker, a paintbrush icon, and choose from the available styles. AEM adds the selected CSS class to the component's wrapper div. The developer only needs to write the HTML markup once and provide CSS classes for each style variation. This eliminates the old approach of creating separate components for each visual variant. For an interview, you should know that style system configuration is stored in policy notes, styles are defined in the component's policy dialog in the template editor, and styles are applied as CSS classes in the component wrapper. It integrates seamlessly with core components and makes AEM implementation significantly more scalable. Question 13. What is client libraries, Clientlibs, in AEM? How do you organize them? Client libraries, commonly called Clientlibs, are AEM's mechanism for managing and delivering front-end assets, CSS and JavaScript, to the browser. They handle dependency management, minification, concatenation, and version delivery. A client lib is a node in the JCR with the type CQ, client library folder. It has a categories property which gives the library one or more category names. It also has a dependencies property listing other category names that must be loaded before this library. Inside the folder, you place a css.txt file listing CSS files to include, and a js.txt file listing JavaScript files to include. In your page HTML template, you use the HTML library manager, dataslyuse.clientlib for the clientlib helper and clientlib.css or clientlib.js calls, or directly use CQ, include clientlib tags. Modern projects using AEM as a cloud service use the asset workflow and clientlib optimization features. The organization best practice is to have page-level clientlibs for critical above-the-fold CSS, component-level clientlibs for component-specific styles, and a global or shared clientlib for site-wide utilities. You can embed one clientlib inside another using the embed property to reduce HTTP requests. In author mode, clientlibs serve unminified files for debugging, while in publish mode they serve minified, gated versions. Knowing clientlib categories, dependencies, and how to include them in page components is important for any AEM front-end work. Question 14. What is Sling Servlet? When would you create one? A Sling Servlet is a Java class that handles HTTP requests for specific resource types, paths, extensions, or selectors. Unlike a standard Java servlet which is mapped to a URL pattern, a Sling Servlet is matched by AEM's script resolution mechanism based on the request's resource type, extension, and selector. There are two ways to register a Sling Servlet. The first way is resource type binding. You use the @Sling Servlet resource types annotation, specifying the resource type, selectors, extensions, and methods. When a GET request comes in for a resource with that Sling resource type, the matching selector, and extension, Sling dispatches to your servlet. The second way is path binding. You use @Sling Servlet paths, though this approach is deprecated and discouraged because path-bound servlets bypass Sling's access control checks. Common use cases for Sling Servlets include custom API endpoints that read or write JCR data, form submission handlers, custom JSON exporters for specific content types, image transformation, or download endpoints, and any case where you need to process a request outside of the standard component rendering pipeline. In your servlet class, you extend SlingSafe method servlet for read-only operations or SlingAll method servlet for read-write operations. You override doGet, doPost, or other HTTP method handlers and use the Sling HTTP servlet request and Sling HTTP servlet response objects just like a standard Java servlet. Question 15. Explain Sling Resource Merger and how it enables inheritance. The Sling Resource Merger is one of AEM's most powerful features for enabling overlay and inheritance without modifying the /libs path. It works by merging two resource trees, one from /apps and one from /libs, presenting them as a single unified resource tree. When you access a resource through the merge route, typically /mnt/overlay for overlays or /mnt/override for Sling models, the resource merger combines the node from /apps with the corresponding node from /libs. Properties defined in /apps override properties from /libs. Child nodes in /apps are merged with child nodes from /libs. If you want to hide an inherited child node, you add a property Sling hide children set to the child node name in your /apps overlay. If you want to override the order of child nodes, you use Sling order before. This mechanism is what makes dialog overlaying possible. For example, if you want to remove a tab from a core component dialog, you create the dialog path in /apps matching the core component's dialog path in /libs, add the specific tab node, and set Sling hide resource to true on it. The Sling resource merger merges the two dialog definitions and hides that tab. Similarly, to add a new field to a core component dialog, you create the dialog in /apps with just the new field node, and the merger combines it with the original. This is far safer than copying the entire dialog from /libs because your overlay only contains your changes and will survive AEM upgrades. Question 16. What is the AEM dispatcher? What does it do? The AEM dispatcher is Apache's web server module that acts as a caching and load balancing layer in front of AEM publish instances. It is not part of AEM itself but is a critical component of every AEM production architecture. The dispatcher serves two primary purposes. First, it caches published HTML pages, assets, and JSON responses at the web server level, dramatically reducing load on the AEM publish instance. When a page is requested, the dispatcher checks if it has a cached version. If yes, it serves the cached file directly from the file system without contacting AEM. If no, it forwards the request to AEM, gets the response, caches it, and serves it. Second, the dispatcher acts as a security layer. It filters incoming requests to block URLs that should not be publicly accessible, like /crx, /system, /console, /libs, and other internal AEM paths. The dispatcher configuration consists of a dispatcher.any file defining farms, filters, cache rules, and virtual host configurations. A farm defines which AEM instances to proxy to, URL filter rules for security, cache folder location and cache rules including which URLs and headers to cache, session management, and load balancing rules across multiple publish instances. Cache invalidation happens through replication. When an author publishes a page, AEM sends an invalidation request to the dispatcher which marks affected cached files as stale. The dispatcher is mandatory in production and must be configured correctly for security and performance. Question 17. What is the AEM replication process? How does content get from author to publish? AEM's replication system is the mechanism that moves content from the author instance to the publish instance. In AEM standard architecture, there are separate author and publish instances. Authors create and edit content on the author instance. When they click the activate or publish button, the replication process transfers that content to the publish instance. Here is the detailed flow. When an author activates a page at /content/mysite/n/home, AEM creates a replication job. The replication agent on the author instance, configured at tools at deployment replication agents, picks up this job. The agent serializes the content from the JCR, the page node and all its children, into a package. It then transfers this package to the publish instance's replication endpoint, typically at /bin/receive. The publish instance deserializes the package and installs it into its own JCR repository. The dispatcher then receives an invalidation request to flush its cache for that page. AEM also supports reverse replication. Content created on the publish instance, such as user-generated content or form submissions, can be replicated back to author. There are different replication agents for different purposes: the default agent for content replication, the flush agent for dispatcher cache invalidation, the static agent for writing files directly to the file system, and the reverse replication agent. For AEM as a cloud service, the replication model changed. Content is distributed via Sling content distribution rather than traditional replication agents. Question 18. What are AEM workflows? Give some common workflow examples. AEM workflows are business processes defined in the AEM platform that can be triggered automatically or manually to process content or assets. They are built on the workflow engine bundled with AEM and follow a visual, step-based model where each step performs a specific action. Workflows consist of 3 types of steps. Process steps perform automated actions, running Java code, calling services, or invoking scripts. They implement the workflow process interface. Participant steps pause the workflow and assign a task to a user or user group for manual action, like reviewing content or approving a design. Dialog participant steps are like participant steps but also present a dialog for the user to fill in data. Common workflow examples in AEM include the DAM asset update workflow, which runs every time an asset is uploaded to the DAM. It extracts metadata, creates thumbnails, processes images for different renditions, and runs media handling steps. The page activation workflow allows adding an approval step before content goes live. An author requests activation, a reviewer approves or rejects. The purge versions workflow regularly deletes old page versions to manage repository size. Custom workflows are common too, for example, sending email notifications when content is published, integrating with an external approval system, or auto-tagging assets using AI services. Workflows are configured in tools or workflow or models. A Java developer implements workflow steps by creating OSGi services that implement the workflow process interface and annotating them with that component. Question 19. What is the AEM authoring interface? What are page editor, experience fragments, and content fragments? The AEM authoring interface is the browser-based environment authors use to create and manage content. The main authoring tool is the page editor, accessible at the /editor.html path. In the page editor, authors see a live preview of their page and can click on components to edit them, drag and drop new components from the component browser, configure templates, and manage page properties. AEM's authoring interface runs in the browser and communicates with the AEM backend via REST APIs and WebSockets for real-time updates. An experience fragment is a component or group of components that includes content and layout and can be reused across pages and channels. They live under /content/experience fragments. They are particularly useful for things like promotional banners, call-to-action blocks, or navigation components that need to appear consistently across multiple pages. When the experience fragment is updated in one place, all pages using it reflect the change automatically. A content fragment is pure structured content without any layout or presentation layer. Content fragments are designed for headless or omnichannel content delivery. The same structured content can be delivered to a website, a mobile app, a voice assistant, or any other channel, each rendering it differently. Content fragments live in the DAM_content/DAM. They are defined by content fragment models that specify the fields and their data types. For the interview, know that experience fragments are layout-aware and designed for page composition, while content fragments are channel-agnostic structured content for headless delivery. Question 20. What is Multi-Site Manager, MSM, in AEM? Multi-Site Manager, or MSM, is AEM's feature for managing content across multiple websites that share a common structure or content. It is particularly useful for organizations with multiple regional websites, brand websites, or localization needs. MSM works through a live copy relationship. You have a blueprint, the master or source site, and one or more live copies, the derived sites. Content changes in the blueprint can be rolled out to live copies automatically or on demand. The relationship between blueprint and live copy is maintained in the JCR through special nodes and properties. Live actions define what happens during rollout. Should child pages be created automatically? Should properties be synchronized? Should components be synchronized? You can configure which parts of the live copy are inherited and which are overridden locally. For localization, AEM provides language copy functionality alongside MSM. You create a master language version of your site, for example in English, then use language copy to create French, German, and Japanese versions. Translation integration workflows can connect AEM to translation management systems to automate the translation process. MSM is configured through the Site Console. You can see the live copy status of any page, rollout changes, and manage the inheritance. Components on live copy pages that have been locally overridden show a special icon to indicate they are no longer inheriting from the blueprint. This is how global enterprises with dozens of country websites manage content centrally in AEM. Question 21. What is AEM's Oak repository and how does TarMK versus MongoMK affect your architecture? Apache Jackrabbit Oak is the JCR implementation underlying AEM 6.x and AEM as a cloud service. Oak replaced the original Jackrabbit implementation and offers improved scalability, clustering support, and query performance. Oak provides two storage backends called node stores. The first is TarMK, tar microkernel, which stores content in tar segment files on the local file system. TarMK is the default for standalone AEM installations and for the author instance in many production setups. It offers excellent performance for single-instance scenarios but does not support clustering by itself. Each AEM instance with TarMK has its own private repository. For author high availability with TarMK, you use a cold standby configuration where a secondary instance continuously replicates from the primary. The second is MongoMK, MongoDB microkernel, which stores content in MongoDB. MongoMK enables AEM author clustering, allowing multiple author instances to share the same repository. This is useful for very high-volume authoring scenarios. However, MongoMK requires MongoDB infrastructure and careful tuning. A shared data store, typically S3, Azure Blob Storage, or a shared file system, stores binary content like images and documents separately from node data in both configurations, enabling efficient storage and sharing of assets. AEM as a cloud service abstracts this complexity with a cloud-native repository backed by object storage, eliminating the TarMK versus MongoMK decision for customers. Question 22. How does AEM search work? What is Oak QueryBuilder? AEM provides a powerful search infrastructure built on top of Apache Lucene indexes maintained by Oak. Content in the JCR can be queried using several query languages, JCR, SQL2, XPath, and AEM's own QueryBuilder API. The Oak Lucene index stores indexed properties from JCR nodes, making full-text and property-based searches fast. The QueryBuilder API is the recommended way to write searches in AEM because it is intuitive and abstracts the underlying query language. You create a QueryBuilder instance through the OSGi service, pass a map of query predicates, and execute the search. Common predicates include type for node type filtering, path for limiting search scope, full text for full text search, property for matching specific property values, tag for tag-based filtering, date range for date filtering, and order by for result ordering. For example, searching all published pages under /content/mysite of type CQ page with a specific tag can be expressed as a simple map of predicates. QueryBuilder also handles pagination through offset and limit predicates. For performance, ensure your queries are backed by appropriate Oak indexes defined under /Oak index. Without a proper index, Oak performs a repository traversal which is slow and logs warnings. Custom Lucene indexes can be configured to index additional properties or perform analyzed text search. For AEM as a cloud service, the index definition goes in your code repository as JSON files committed to Git and deployed through Cloud Manager. Understanding search and indexing is important for AEM backend developers. Question 23. What is the AEM Package Manager? How do you deploy code and content? The AEM Package Manager is the tool for packaging, installing, and managing content and code bundles in AEM. It is accessible at /crx/packmg. A content package is a zip file containing a serialized subset of the JCR repository, essentially a snapshot of nodes and properties in a specific path. Packages are used for deploying code from development to staging to production, migrating content between environments, sharing components or templates, and installing AEM feature packs from Adobe. Packages are built using Maven and the Adobe Content Package Maven plugin, or through the Package Manager UI. The standard AEM project structure uses the AEM project archetype, a Maven archetype that generates a multi-module Maven project. The typical modules include UI.content for the /content path with site content and MSM configurations, UI.apps for the /apps path with components, templates, and configurations, UI.config for OSGi run mode configurations, UI.frontend for the frontend build producing Clientlibs, and core for the Java bundle with Sling models and OSGi services. AEM as a cloud service uses Cloud Manager pipelines for deployment. You commit code to Git, Cloud Manager triggers the pipeline, builds the code, runs quality gates including code quality checks and security scans, and deploys to AEM environments. Direct package installation is not supported in AEM as a cloud service production environments, which enforces proper deployment discipline. Question 24. What is the difference between forward and reverse replication in AEM? Forward replication is the standard content flow from author to publish. When an author activates or publishes content, the replication agent on author serializes the content into a package and sends it to the publish instance's /bin/receive endpoint. This is how pages, assets, and configurations move from authoring to the live website. Reverse replication is the opposite flow. Content is created or collected on the publish instance and needs to be sent back to author. This is less common but important for specific use cases. The primary use case for reverse replication is user-generated content, forms submitted by website visitors, comments, ratings, and other data created on publish that needs to be stored in the central author repository or processed. Another use case is collecting content created by frontline workers using AEM's mobile apps or remote publishing features. Reverse replication uses a special outbox on the publish instance. Content placed in /var/replication/outbox is picked up by the reverse replication agent on author and pulled into the author repository. The reverse replication agent is configured on the author instance and pulls the publish outbox at regular intervals. In modern AEM architectures, user-generated content often bypasses JCR entirely and is stored in external databases or cloud services, reducing the need for reverse replication. But understanding both directions is important for AEM architecture interviews. Question 25. What is AEM tagging and how is it implemented? AEM's tagging system is a hierarchical taxonomy system that allows content and assets to be classified and organized. Tags live in the JCR under /content/CQ tags and are organized in namespaces. For example, a properties namespace might contain tags like properties, residential and properties, commercial. Tags are created and managed in tools, tagging. Each tag has a CQ tag primary type and properties for title, description, and localized variants. Content is tagged by adding the CQ tag's multi-value property to a page or asset's JCR content node. Tags integrate with search. You can filter search results by tag. In component dialogs, you use the tag field type to allow authors to apply tags to components or pages. Tags are powerful for implementing faceted search, content targeting, and cross-site content aggregation through the list components tag-based filter. AEM Tag Manager API provides programmatic access to tag operations, creating tags, applying tags, searching by tag. Tagging also supports smart tagging of assets using Adobe Sensei AI. When images are uploaded to the DAM, the Smart Tag service analyzes the image content and automatically applies relevant tags from a configured dictionary. This is especially useful for large media libraries. In the context of content fragments, tags can be applied to fragments and used for filtering in headless delivery. For interviews, know that tags live in /content/CQ tags follow a namespace value hierarchy, are stored as CQ tags properties on nodes, and integrate with both search and personalization features. Question 26. How does AEM handle user management and permissions? AEM's user management is built on the Apache Jackrabbit access control model, which follows the JCR standard for access control. Users, groups, and permissions are stored in the JCR under the /home path. User accounts are at /home/users and groups at /home/groups. Each user has a profile node with properties like display name, email, and custom properties. AEM provides two main ways to manage users and groups: the Users Console in the Security Tools section, and via API in custom code using the User Manager and authorizable interfaces. Permissions are defined as access control lists on JCR nodes. An ACL on a node specifies which principals, users or groups, have which privileges, read, write, modify, replicate, delete, on that node and optionally its descendants. The standard privileges include JCR, read for reading a node, JCR, write for modifying properties and child nodes, JCR, modify properties for changing properties, CRX, replicate for activating content, and rep, write which aggregates write-related privileges. AEM has several built-in groups including administrators with full access, authors with authoring privileges, DAM users for DAM access, and workflow users. For production environments, best practices include creating functional groups for each role, assigning users to groups rather than granting permissions directly to users, following the principle of least privilege, and using closed user groups, CUGs, for restricting access to specific sections of the website to authenticated users. Question 27. What are AEM's run modes and why are they used? Run modes in AEM allow you to configure your AEM instance differently based on its role in the infrastructure, author versus publish, development versus staging versus production. Run modes are simple string identifiers that are activated at startup. The built-in run modes include author, publish, dev, stage, and prod. An AEM instance can have multiple run modes active simultaneously. For example, an author instance in production might have both author and prod run modes active. Run modes affect which OSGi configurations are applied. In an AEM Maven project, OSGi configurations are placed in folders like /apps/urap/ostraconfig/config for configurations that apply to all run modes, /apps/urap/ostraconfig/config.author for author-only configurations, /apps/urap/ostraconfig/config.publish for publish-only configurations, and /apps/urap/ostraconfig/config.prod for production-only configurations. For example, a logging configuration might be set to debug level in /config.dev but warn level in /config.prod. A dispatcher flush agent configuration would only exist under /config.author because only the author instance needs to invalidate the dispatcher cache. The AEM instance's run mode is set by the sling.run.modes property in the sling.properties file or by the start script parameter, author. In AEM as a cloud service, the platform automatically sets appropriate run modes based on the environment tier. Run mode awareness is fundamental to building configurable, environment-aware AEM applications. Question 28. What is AEM's event handling system? How do you observe JCR changes? AEM provides a robust event handling system for observing and reacting to changes in the JCR repository, OSGi service lifecycle, and higher-level AEM events. There are several layers to this system. At the JCR level, you can register an observation listener to receive events when nodes are added, removed, or modified under a specific path. You get access to the JCR Observation Manager and register your listener specifying the event types, node_added, node_removed, property_changed, the path, and whether to observe the path recursively. At the Sling level, you use the Resource Change Listener interface, a cleaner API for observing resource changes. You annotate your OSGi component with that component and implement Resource Change Listener, then use @designate annotations or properties to configure which paths and change types to listen to. At the OSGi level, AEM uses the Event Admin service for distributing events between bundles. You can both send and receive events through the Event Admin API. AEM itself publishes high-level events through Event Admin for workflow events, replication events, DAM events, such as when an asset is updated, and page events like page publication or deletion. You implement an event handler OSGi service, annotate it with event.topics to specify which event topics to listen for, and handle the events in the handle event method. A common real-world use case is listening for the DAM asset created event to trigger a custom processing step when a new asset arrives in the DAM, or listening for page publication events to invalidate an external cache. Question 29. What is the AEM query debugger and how do you optimize slow queries? Query performance is a common production issue in AEM, and understanding how to diagnose and fix slow queries is important for any AEM developer. The query debugger is available in AEM through several tools. The Query Explain feature, accessible via the AEM web console or the /libs/granite/operations/content/diagnosis/queryperformance.html page, allows you to enter a query and see its execution plan, which indexes it uses, and whether it performs a repository traversal. Repository traversals are the enemy of performance. They scan every node in the repository, which is extremely slow for large repositories. The slow query log and error.log shows queries that exceeded a configured threshold. When you see a slow query, the first step is to understand what it is trying to do using the explain functionality. If the explain output shows no index used and mentions traversal, you need to create or update an oak index. Oak indexes are configured under /oak index in the JCR. Lucene property indexes are the most common. You configure them to index specific node types and property names. For full text search, you use an analyzed Lucene index. When creating a custom index, you must also run a reindex of the repository. In AEM as a cloud service, index definitions are committed to Git as JSON files and deployed through Cloud Manager. Reindexing happens automatically in the cloud environment. Beyond indexes, query optimization techniques include restricting the search path, using specific node types, avoiding or conditions that force full scans, and using pagination with offset and limit. Question 30. What is AEM Sling context-aware configuration? Sling context-aware configuration, often called CA-config, is a framework introduced in AEM 6.2 for managing configurations that vary by context, typically by site, by language, or by environment. The problem it solves is this: in large AEM implementations with multiple sites, you often need site-specific configurations, different API endpoints, different third-party service keys, different feature flags. Before CA-config, developers hard-coded these in OSGi configurations or used complex inheritance workarounds. CA-config provides a structured, hierarchical configuration system. Configuration values are stored as nodes in the JCR_conf. You define a configuration schema using Java interfaces annotated with @configuration. For example, you might define a configuration interface for your analytics service with fields for tracking ID and endpoint URL. In the JCR, you store the actual values under /conf/mysite/settings/cloudconfig/analytics. On your site's root page, you set the CQ/conf property to /conf/mysite to associate the site with that configuration bucket. In your Sling model or OSGi service, you inject the configuration resolver service, get the resource from the request, and call getValueMap on the configuration. AEM walks up the content hierarchy to find the appropriate configuration. This hierarchical lookup means you can define default configurations at /conf/global and override specific values at /conf/mysite. For modern AEM development, CA-config is the standard way to handle environment-aware, site-specific configurations instead of hard-coding values or using overly complex OSGi factory configurations. Question 31. Explain the AEM Sling Resource Resolver. How do URL mapping work? The Sling Resource Resolver is the central API for accessing JCR content in AEM. Every request to AEM has a resource resolver associated with it, bound to the logged-in user's session. Through the resource resolver, you can resolve paths to resource objects, adapt resources to different types including Sling models, search for resources using Sling queries, and perform CRUD operations on the content tree. URL mapping in Sling is powerful and bidirectional. Outbound URL mapping, from a JCR path to a URL, is done through the resource resolver's map method. Inbound URL mapping, from a URL to a JCR path, is done through the resolve method. The mapping rules are configured in the Sling URL mapping service. You can define path prefixes that are stripped, added, or transformed. For example, you might configure /content/mysite/n to map to just / at the web server level, so authors work with /content/mysite/n/home but visitors see /home. Vanity URLs, custom short URLs configured per page using the Sling vanity path property, are another form of URL mapping. A resource resolver is always tied to a user session and must be closed after use to prevent session leaks. In OSGi services that are not request scoped, you obtain a resource resolver using the resource resolver factory with appropriate credentials, typically a service user. For AEM as a cloud service, service users are defined in repository initialization scripts. Understanding the resource resolver and its lifecycle, always close it, always use try with resources, is critical for writing correct, leak-free AEM code. Question 32. What is AEM's Page Manager and how do you work with pages programmatically? Page Manager is AEM's Java API for managing CMS pages, creating, moving, copying, and deleting pages. It wraps the lower-level JCR operations with CMS-aware logic, such as handling MSM inheritance during page operations and triggering appropriate events. To get a Page Manager instance, you adapt a resource resolver to Page Manager using resourceresolver.adaptTo PageManager.class. The page interface represents a CMS page with convenient methods like getTitle, getDescription, getPath, getProperties for accessing page-level properties, getTemplate for the template reference, listChildren for iterating child pages, and getContentResource for accessing the JCR content node. To create a page, you call PageManager.create passing the parent path, the page name, the template path, and the title. To copy a page, you use PageManager.copy. Moving and renaming use PageManager.move. For deleting, PageManager.delete. When working with page properties, you call page.getProperties, which returns a value map of the JCR content node's properties. Custom page properties added through the Page Properties dialog are accessible through this value map. For reading properties deeply nested in the component tree under a page, the actual component instances on the page, you traverse the content tree using resource.getChild and resource.listChildren. The page model is what Sling model page components adapt from. When you extend the core components page model, you are extending a Sling model that ultimately gets the current page through the Page Manager. For any AEM backend developer, fluency with the Page and Page Manager APIs is fundamental. Question 33. What is the Asset Manager API in AEM? How do you handle assets programmatically? The Asset Manager API in AEM provides programmatic access to digital assets stored in the DAM. To get an asset manager, you adapt a resource resolver using resourceresolver.adaptToAssetManager.class. To create or upload an asset, you call AssetManager.createAsset passing the path in the DAM, an input stream with the asset binary, the MIME type, and a boolean indicating whether to update if it already exists. To retrieve an asset, you resolve the DAM path to a resource and adapt it to an asset using resource.adaptToAsset.class. The asset interface provides methods like getPath, getMetadataValue for reading XMP or EXIF metadata properties, getRenditions for listing all renditions, including the original and any generated thumbnails, and getOriginal for the original binary rendition. Renditions are stored under /content/dam/path/to/asset/jcr, content/renditions. The DAM asset update workflow is triggered automatically when assets are created or updated through Asset Manager. This workflow runs extraction, thumbnail generation, and other processing steps. For custom metadata, you access the asset's metadata node at /content/dam/path/to/asset/jcr, content/metadata and read or write properties using the JCR API. The DAMUtil helper class provides static utilities for common DAM operations. In AEM as a cloud service, large-scale asset processing uses asset compute microservices in Adobe I/O runtime instead of the traditional workflow-based approach, enabling cloud-native, scalable asset processing. Understanding the Asset Manager and asset interfaces is essential for any DAM integration work. Question 34. What is AEM's Externalizer service? Why is it important? The Externalizer service in AEM converts JCR paths into full absolute URLs, including the domain and protocol. This is critical in several scenarios. First, when generating emails or notifications that contain links to AEM pages, you cannot use relative URLs. Second, in server-side code that generates URLs for external systems or APIs. Third, in workflows or scheduled tasks running outside of a web request context where there is no request URL to derive an absolute URL from. The externalizer is configured with domain mappings for different instances. You define domains for author, publish, and local instances in the DayCQ link externalizer OSGi configuration. For example, publish maps to https://www.mysite.com and author maps to https://author.mysite.com. In your code, you inject the externalizer OSGi service and call externalizer.externalLink, resource resolver, publish, /content/mysite/n/home, which returns the full URL https://www.mysite.com/content/mysite/n/home, and with Sling URL mapping applied, it might become https://www.mysite.com/n/home. The externalizer.absoluteLink method uses the current instance's domain. This service must be configured correctly per environment. The configuration goes in run mode specific OSGi config folders. In AEM as a cloud service, the externalizer service automatically picks up the environment's domain from the Cloud Manager environment configuration, simplifying multi-environment management. For email use cases, always use the externalizer rather than hard-coding domain names, ensuring your code works across all environments. Question 35. What is AEM's content fragment model and how does it enable headless delivery? Content fragment models are schemas that define the structure of content fragments in AEM. They specify what fields a content fragment has: titles, text fields, date fields, enumeration fields, Boolean fields, content references, fragment references, and multi-field arrays. Models are created in tools, assets, content fragment models. Once a model is created, authors can create content fragments based on that model in the DAM browser. A content fragment is pure structured content without any presentation layer, making it ideal for headless content delivery where the same content needs to appear on a website, a mobile app, a smart display, or any other channel. AEM exposes content fragments via two APIs for headless delivery. The REST Assets API provides CRUD operations on content fragments through standard HTTP endpoints. More powerful is the GraphQL API, introduced in AEM 6.5 and central to AEM Headless. AEM generates a GraphQL schema automatically from your content fragment models. You query fragments using GraphQL queries, specify exactly which fields you need, and get back JSON responses. AEM supports persisted queries, GraphQL queries saved in AEM and executed by name, which offer better performance through caching and are the recommended approach for production. Content fragment references in models allow fragments to reference other fragments, enabling a composable content architecture. For the interview, understand that content fragment models define structure, content fragments are the instances of that structure, and GraphQL or REST APIs deliver them to any channel without any AEM rendering layer involved. Question 36. What are AEM Launch and AEM Cloud Service? How is Cloud Service different from on-premise AEM? AEM as a cloud service is Adobe's cloud-native, SaaS version of AEM that replaces the traditional on-premise or managed service deployment model. It fundamentally changes the operational model in several ways. First, AEM as a cloud service runs on Kubernetes in Adobe's cloud, with automatic scaling, automatic AEM version updates, and no customer access to underlying infrastructure. There are no version upgrades to perform manually. Adobe continuously updates the platform. Second, the architecture separates author, publish, and preview into independent tiers that scale independently. The publish tier uses a stateless, containerized model that can scale to thousands of instances. Third, content distribution uses Sling content distribution to push content from author to publish instead of traditional replication agents. Fourth, the repository model uses a cloud-native, segment store backed by Azure Blob Storage. Fifth, all customization must go through Cloud Manager pipelines, no direct package installation in production. Code quality gates are enforced. Sixth, OSGi configurations must be committed to Git and deployed through pipelines, not configured via the Felix console in production. For developers, the main practical differences are the content distribution model replacing replication, stricter code quality requirements enforced by the Cloud Manager quality gate, the need for repository initialization scripts for service users, and the use of cloud-native asset processing through asset compute. AEM launches, not to be confused with AEM as a cloud service, is a feature for preparing future content changes. Launches create a parallel version of site content that can be worked on and scheduled for publication on a future date. Question 37. What is the AEM Sling job mechanism? How do you create asynchronous jobs? The Sling job mechanism provides a reliable, distributed job queue for processing tasks asynchronously in AEM. Unlike simple background threads, Sling jobs are persisted in the JCR under /var/eventing/jobs, ensuring that jobs are not lost if AEM restarts. Jobs are also distributed aware. In a cluster, a job submitted on one instance can be processed by any instance in the cluster. The Sling job system has two main components. Job Manager is the service used to add jobs. You call jobmanager.addJob passing the job topic and a map of job properties. Job Consumer is an OSGi service that processes specific job topics. You implement the Job Consumer interface, annotate the service with that component, and use the Sling.job.topic property to specify which topic your consumer handles. Job topics follow a reverse domain naming convention, for example, com/mycompany/myapp/process-asset. In the process method, you receive the job object, read its properties, perform your work, and return jobresult.ok for success, jobresult.failed for a retriable failure, or jobresult.cancel for a permanent failure. Common use cases include sending emails triggered by user actions, processing large content migrations in the background, indexing content in external search systems after publication, and integrating with external systems that should not be called synchronously. The Sling event and job console at /system/console/Sling event shows active, queued, and failed jobs. For high-throughput job processing, you can configure dedicated queues with thread pool sizes and retry policies. Question 38. What is AEM's Granite UI? How do dialogs and field types work? Granite UI is AEM's component library for building administrative user interfaces, primarily the component dialogs, page properties dialogs, and touch UI admin pages. It provides a rich set of UI widgets mapped to JCR node structures. When you create a component dialog in _CQ_dialog/.content.xml, you are building a Granite UI form. The dialog structure follows a specific pattern. The root node is a CQ, dialog of resource type CQ/GUI/components/authoring/dialog. Inside it, you have a content node of type Granite/UI/components/coral/foundation/container, then a layout node defining whether items appear in tabs or as a fixed layout, then an items node containing your form fields. Granite UI provides many field types. Text field maps to a single-line text input. Text area maps to a multi-line text input. Checkbox is a Boolean toggle. Select provides a drop-down. Path field allows browsing and selecting a JCR path, useful for linking to pages or assets. File upload provides asset upload. Hidden stores a value without UI. Date picker provides a date and time input. Multi-field allows repeating a set of fields for multi-value properties. Root provides a rich text editor with configurable toolbars. Tag is a tag picker. The values entered in dialog fields are saved to JCR properties on the components node under JCR content. In your Sling model, you access these properties via @ValueMapValue annotations mapping to the property names defined in the dialog field's name attributes. Understanding how dialog field names map to JCR properties and how to read them in Sling models is a core AEM development skill. Question 39. How does AEM's in-place editing work? In-place editing is one of AEM's most powerful authoring features. It allows authors to edit content directly on the page, in context, without opening a separate dialog. This makes editing feel natural and immediate. For text components, clicking the component in edit mode activates the rich text editor directly on the component, showing formatting toolbars inline. Authors type and format text directly in the component without leaving the page preview. For titles and simple text fields, clicking enables direct text editing, the author types and the content updates immediately. In-place editing is configured in the components_cq_edit config.xml or through the in-place editing node in the component structure. The in-place editing node has a config path property pointing to the RTE configuration and a child ID that links it to the rendered HTML element. AEM uses the edit context, the HTML element marked with date in-place editing attributes, to know which DOM element to activate for editing. For rich text, the RTE configuration defines which toolbar buttons and formatting options are available, bold, italic, lists, links, styles, and which HTML elements are allowed in the output. This configuration is centralized in /libs/cq/GUI/components/authoring/root and can be overlaid. In-place editing is deeply integrated with the page editor's edit mode, layer system, and WCM mode awareness. Components check the WCM mode to determine whether to render authoring controls or clean output. For interviews, understanding how in-place editing connects to RTE configuration and edit mode is valuable. Question 40. What are experience fragments and how do they differ from reusable components? Experience fragments are groups of components combined with content and layout that form a complete experience, like a promotional banner, a product card, or a testimonial section, that can be reused across multiple pages and even across multiple channels. They live under /content/experience fragments in the JCR and are authored like pages, with a template, an editable layout container, and components. The key difference from a simple reusable component is that an experience fragment carries its own authored content. A reusable component is a code artifact, its structure is defined by developers, and the content is always specific to the page it appears on. An experience fragment is a content artifact, both the structure and the content are managed by authors and can be reused across pages. When an experience fragment is referenced on a page using the experience fragment component, AEM renders the content from that shared fragment. If the fragment is updated in one place, all pages referencing it automatically show the updated content. Experience fragments support variations, different versions of the same fragment for different contexts, for example, a primary web variation and a simplified email variation of the same content block. They can be exported to different formats. Adobe Target offers for personalization, HTML fragments for email systems, and JSON for headless delivery. Experience fragments integrate with Adobe Target for A/B testing and personalization. You can export a fragment as a target offer and use it in target activities. This makes them powerful for omnichannel campaign management and experience personalization. Question 41. What is the WCM mode in AEM? How do components behave differently in author versus publish? WCM mode, which stands for Web Content Management Mode, is an AEM concept that tells components what rendering context they are in: edit mode, preview mode, design mode, disabled mode, or publish mode. In author mode within the page editor, the WCM mode is typically edit. In this mode, components should render their authoring placeholders, empty component messages, drag and drop targets, and any other authoring aids. When the author switches to preview, WCM mode becomes preview and components should render as they would on the publish instance, without authoring overlays. On the publish instance, WCM mode is disabled, meaning no authoring infrastructure should be rendered. In your HTML template, you check WCM mode using the WCM mode expression, available through the WooMode global object. You might conditionally include authoring styles, empty placeholders, or edit action markup based on whether WooMode.edit is true. In Sling models or Java classes, you can inject the WCM mode service and call request.adapt to WCM mode.class to get the current mode. This is important for several reasons. Components should not render debugging information or edit mode markup in production. Clientlibs used only for authoring, like those providing component resize handles or drag handles, should only be included in edit mode. Some components have special empty state rendering that prompts authors to configure the component, which should not appear on the live site. Properly handling WCM mode is what separates a well-implemented AEM component from one that leaks authoring markup into production. Question 42. How does AEM's responsive layout work? AEM's responsive layout system provides a grid-based layout mechanism that allows authors to control how components appear at different viewport widths, desktop, tablet, and mobile. It is built around the layout container component, which implements a 12-column responsive grid. When authors enter layout mode in the page editor, by clicking the layout icon in the mode switcher, they can resize components on the grid by dragging resize handles for each configured breakpoint. The breakpoints are defined in the page template's layout policy, typically desktop at 1200 pixels wide, tablet at 768 pixels, and mobile at 375 pixels. For each breakpoint, the author can specify how many of the 12 grid columns a component should span. AEM generates responsive CSS classes for each component based on these authored column values. The layout container renders as a div with a class that activates the grid system. Each component inside gets classes like call xs12 for mobile, call sm6 for tablet, and call md4 for desktop. The grid CSS, typically based on a bootstrap-like grid, handles the responsive behavior using media queries. In the page's Clientlibs, the grid CSS must be included. Developers can configure how many columns the grid uses and what the breakpoints are. The responsive grid is part of AEM core components and works best when combined with the style system for applying different visual treatments at different breakpoints. For the interview, understand that layout mode is for authors, the layout container manages the grid, breakpoints are configured in the template policy, and the output is standard CSS class-based responsive design. Question 43. What is AEM Sling data binding and how does content sync work for mobile apps? Content sync was AEM's older mechanism for delivering AEM content to mobile applications built with PhoneGap or Apache Cordova. It exported selected content as a zip file that could be downloaded and cached on the device, enabling offline capabilities. The content sync framework allowed configuring which content types and paths to export, and it tracked changes so only modified content needed to be re-exported in updates. However, content sync is legacy technology from the AEM mobile era. Modern AEM integration with mobile apps uses the headless capabilities, content fragments delivered via GraphQL or the Assets HTTP API. This approach is far more flexible because it does not require a specific mobile framework and works with React Native, Flutter, or native iOS and Android applications. Sling data binding refers to the capability within HTL and Sling models where component data is automatically mapped from JCR properties to Java fields. The add-value map value annotation in Sling models is the primary mechanism. It reads the property from the resources value map, which is essentially a map of the JCR node's properties, and injects it into the annotated field. Type conversion is handled automatically. Strings, integers, booleans, dates, and arrays are all supported. This Sling data binding eliminates boilerplate code for reading JCR properties and is one of the main reasons Sling models are preferred over older use API approaches. Understanding the full stack from JCR storage through Sling model binding to HTL rendering is fundamental to AEM component development. Question 44. What is AEM Forms container versus AEM adaptive forms? AEM Forms is a separate capability within AEM focused on creating and managing digital forms and documents. Within AEM Forms, there are two form technologies. Classic AEM Forms, sometimes called Foundation Forms, are older form components included in the base AEM platform. They allow authors to drag and drop form fields onto pages and submit to configured endpoints. They are simpler but lack advanced features and are considered legacy. Adaptive forms are the modern, recommended form technology in AEM Forms. An adaptive form is a responsive, accessible, intelligent form that adapts its behavior and layout based on device, user data, and rules. Adaptive forms are created in the AEM Forms interface, not in the site's page editor. They support complex validation rules, conditional visibility, showing or hiding fields based on other field values, pre-filling from data sources, save and resume, allowing users to save a partially completed form and come back later, and multi-step wizard layouts. Adaptive forms can submit data to multiple targets, JCR, REST endpoints, email, databases, and document services. The document of record feature automatically generates a styled PDF snapshot of the submitted form. Adaptive forms are schema-driven. You can bind them to an XML schema, JSON schema, or form data model which defines the data structure. The form data model is an abstraction layer connecting forms to backend data sources, REST services, databases, SOAP services, and provides read and write operations. For the interview, know that adaptive forms are the modern approach, are schema-bound, support complex rules and pre-fill, and can generate documents of record. Question 45. What is AEM Sling Rewriter and how is link rewriting handled? The Sling Rewriter is a pipeline-based post-processing framework in AEM that transforms the HTML response after it has been generated by the component rendering pipeline. It intercepts the servlet output and passes it through a series of transformers that can modify the HTML before it is sent to the browser. The primary use case for the Sling Rewriter in AEM is link rewriting, transforming internal JCR paths in ref and SRC attributes into proper external URLs. For example, components might generate links with raw JCR paths like /content/mysite/n/aboutus. The link checker transformer rewrites these to external URLs like /n/aboutus.html or https://www.mysite.com/in/about-us based on Sling URL mapping configuration. The rewriter is configured through OSGi service factory configurations for the HTML rewriter CT service and through node configurations in /libs/cq/config/rewriter and /apps/urap/config/rewriter. Transformers are chained. Each one reads SAX events from the previous transformer and emits modified SAX events to the next. Standard transformers in AEM include link checker for validating and transforming links, mobile redirect for redirecting mobile visitors, and a general heightmo parser for encoding. The Sling rewriter also enables globally applying transformations like adding tracking parameters to all links, injecting external CDN domain prefixes for assets, or stripping development-only comments from HTML. For advanced AEM projects, writing custom rewriter transformers, by implementing the Transformer Factory interface, allows powerful output post-processing without modifying individual components. Question 46. How does AEM Sling authenticate users? What is the token authentication handler? AEM supports multiple authentication mechanisms through Sling's authentication handler framework. Each authentication handler is responsible for detecting credentials in incoming requests and authenticating users. The framework allows multiple handlers at different paths, selected based on the request path. The main authentication handlers in AEM are the form-based authentication handler, which handles post to /j_security_check with username and password, creates a session, and sets a cookie, and the token authentication handler, the default in modern AEM, which creates a login token instead of a traditional JCR session. The token authentication handler works as follows. When a user logs in, AEM validates their credentials against the user store, typically the JCR or an LDAP directory. On success, AEM creates a login token, a cryptographically signed string containing the user ID, expiration time, and a server-side secret. This token is stored in the user's JCR profile under /home/users and also sent to the browser as a cookie named login token. On subsequent requests, the handler reads the cookie, validates the token against the stored value, and authenticates the user without needing to re-verify the password. Token authentication is stateless from the session perspective, making it better suited for clustered and cloud deployments. AEM also supports SAML 2.0 authentication for enterprise single sign-on. The SAML authentication handler integrates with corporate identity providers like Okta, Azure AD, or Ping Federate. For public sites with personalization, AEM supports OpenID Connect via the Auth0 or similar integration. Question 47. What is AEM's translation integration framework? The Translation Integration Framework in AEM provides a structured way to connect AEM to external translation services and manage the end-to-end translation workflow for multilingual content. For enterprises with global websites, managing translations at scale requires automation. Manually copying content to translation tools and back is error-prone and slow. AEM's Translation Integration Framework consists of several parts. Translation configuration. Cloud services connect AEM to translation service providers, either machine translation services like Microsoft Translator or Google Cloud Translation, or human translation management systems like LionBridge, SDL, or translations.com. These connectors implement the translation service OSGi interface. Translation rules define which content in the JCR should be translated, which node types, which property names, and which content paths. For example, you might configure rules to translate JCR, title and JCR, description properties of CQ, page nodes under /content/mysite. Translation projects orchestrate the workflow. When an author initiates translation of a page or a set of pages, AEM creates a translation project and a translation job. The job packages the content according to the translation rules into ZLIF format, an open standard for translation exchange, and sends it to the configured translation service. When translations are returned, AEM imports them and populates the translated language copies of the pages. Language copy refers to the localized versions of site content, for example, /content/mysite/fr for French, and is tightly integrated with MSM so structural changes in the master language can be rolled out to language copies. Question 48. How do you implement a custom AEM scheduler? AEM provides two ways to implement scheduled background tasks, the Sling scheduler and the Sling job mechanism. For simple periodic tasks, the Sling scheduler is the easiest approach. You create an OSGi component that implements the runnable interface and annotate it with that component with immediate set to true. You add a at designate annotation pointing to a configuration interface that defines the CRON expression. In the activate method, you use the injected scheduler service to register your runnable with a schedule. The scheduler.schedule with fixed delay or scheduler.expr format using a CRON expression allows you to run tasks every minute, every hour, every day at a specific time, or any other schedule. The CRON format in Sling uses 6 fields: seconds, minutes, hours, day of month, day of week. For example, 002** runs at 2 a.m. every day. A very important consideration for schedulers in clustered AEM environments is the run-on property. By default, a scheduler runs on every instance in a cluster. But for tasks that should only run on one instance, like a task that reads and writes to an external system, you set scheduler.runOn to single or configure it to run on the leader node only. The scheduler service handles this automatically when configured. For tasks that require more reliability, persistence, and retry logic, use Sling jobs instead. They persist to the JCR and survive server restarts. Real-world scheduler use cases include nightly content cleanup, periodic data synchronization with external systems, scheduled cache invalidation, and generating sitemap XML files. Question 49. What are common AEM performance issues and how do you troubleshoot them? Performance troubleshooting in AEM requires understanding the full request lifecycle and knowing where bottlenecks commonly occur. The most common AEM performance issues are slow queries, session leaks, large component trees, missing dispatcher cache, and thread contention. For slow queries, the tools are the Oak Query Performance page at /libs/granite/operations/content/diagnosis/queryperformance.html, the slow query log, and the explain query feature. Fix by creating appropriate Oak-Lucene indexes. For session or resource resolver leaks, where code opens sessions or resolvers but does not close them, the error log shows repository session leak messages. Fix by auditing code for unclosed resource resolvers and using try with resources. For large component trees, pages with hundreds of deeply nested components, each component triggers a rendering cycle. Fix by using Sling, include caching, lazy loading, or restructuring the page architecture. Missing dispatcher cache is often the root cause of high AEM publish load. Check dispatcher cache hit rate using the dispatcher statistics page. Fix by ensuring pages are cacheable, they should not have request parameters that prevent caching, their headers should not have cache control no cache, and the dispatcher/cache rules should allow caching. Thread contention shows up as thread dumps with many threads blocked waiting for locks. Capture thread dumps using kill-3 stack or the AEM thread dump button and analyze with tools like fastthread.io. Additional troubleshooting tools include the AEM health check at /libs/granite/operations/content/health reports, the Granite performance dashboard, and AEM's built-in request logger. Question 50. What is AEM's best practice for local development setup? What tools are essential? A well-configured local development environment is essential for productive AEM development. Here is the recommended setup for modern AEM projects. Start with the AEM SDK. For AEM as a cloud service, Adobe provides an SDK jar that includes the author and publish quick start jars and the dispatcher tools. For AEM 6.5, use the standard AEM jar with the license.properties file. For IDE, IntelliJ IDEA Ultimate or Eclipse with AEM developer tools, also called AEM DT, are the most popular choices. AEM DT provides automatic sync of code changes to a running AEM instance through the VLT file vault integration. The project structure follows the AEM Maven archetype. Use the latest version from Adobe's GitHub. This gives you the correct module structure with UI.apps, UI.content, UI.config, UI.frontend, and core modules. For front-end development, use the front-end build module with Webpack or Vite, which compiles your TypeScript, SCSS, and JavaScript into AEM Clientlibs. Use the AEM Maven plugin with auto-install single package profile for quick deployments. Install the repo tool, a command-line VLT wrapper, for bidirectional file sync. Use the AEM Chrome plugin or CRXDE Lite at /crx/da for exploring and debugging the JCR. The Sling log tracer, available at /system/console/slinglog, allows enabling request-scoped debug logging for specific classes without restarting AEM. For unit testing, use the AEM mocks library from io.wcm. It provides a JUnit 5 compatible AEM context for testing Sling models and OSGi services without a running AEM instance. These tools together make AEM development fast, reliable, and maintainable.